GRAS. But I mean, that would be kind of maybe too much on one topic. So if you want, I can give you a reference to an updated version of this a little later. But for the time being, what I want to do is I want to move on to a different application of clustering. So here we were clustering strings based on string distances. The next application I want to look at uses clustering with a different objective. So think back for a moment about how the similarity matching works. So what I said was T1 through Tn here are different terms. As a user, you have applied some 3 or 4 different keywords here, and I'm looking for documents that contain these 3 or 4 keywords. Now, most of us, when we are, as users, most of us are lazy, so you aren't usually very careful about constructing your query. I mean, you give Google 2 or 3 keywords and you expect it to do magic. So the problem with that is, because we are essentially doing keyword matching, if you use frequently used or commonly occurring keywords, you'll be fine. But you might miss out on documents that talk about the same thing but use slightly different terminology from what you've been using in your query. So recall the example that I talked about earlier. You might phrase your query in terms of automobile pollution, and a useful document might cause about emissions from cars. So the document and the user, I mean the information content matches, but there's no vocabulary match, in the sense that you don't have word level matches. So this is kind of known as the standard vocabulary mismatch problem. And one of the standard ways in which we attempt to handle this problem is via something called query expansion. Query expansion is you take the user's query, and because the user is lazy, he or she supplies only 2 or 3 keywords. But you automatically find additional words related to those words and add them to the query behind the scenes, so that the query ends up matching additional documents as well. So if you could somehow use something like a thesaurus, which as I mentioned earlier is kind of difficult to use, but if you could effectively use thesaurus and you get a query like motor vehicle emissions or pollution, you'd add things like automobile or car or something to it. Okay, so the main idea there, so the main technique that I've talked about is query expansion, and what you want to do is, given a query, you want to add related terms related to the query words to the query, so that you match more useful documents. So the obvious resource that you might want to use, like I said, is a thesaurus, except that if you're using general purpose thesauri like Rogers thesaurus or WordNet, then you run into the problem that I talked about earlier. So you have, a word could have multiple senses, and even a short 3-word query, you might not know which sense the user means. So another very frequently cited example is Jaguar. Do you mean Jaguar the animal? Do you mean Jaguar the operating system? Or do you mean Jaguar the car? So there's a lot of work being done recently about search diversification to handle general queries like this, but that's a kind of different subject. So confining ourselves for the time being to traditional searching, where given a query word, you want to add additional related words in the hope that that will match more documents. If you know that your search is kind of confined to a specific domain, that makes your task a lot easier, because very often for specific domains you'll have kind of domain-specific thesauri or ontologies available. So InSpec and Mesh are 2 such examples. Mesh is medical subject headings or such, I forget what the expansion is. But that's an ontology of medical terms. So if you know you are searching within medical literature, then then the question of kind of having ambiguous words and not knowing what sense to map a particular word to, that problem is much less severe. So you might be able to use a thesaurus-like mesh fairly effectively. What we are going to look at instead is how you might go about constructing an automatic thesaurus. And this would be, as the title suggests, based on kind of gathering information about word association. So you basically look for whether words co-occur together. So here's what an association is formally in this context. If two terms co-occur within the same context, they constitute an association. So the context could be defined as a sentence, it could be defined as a paragraph, it could be defined as something as loose as a full document. You get the general idea. So one association looks like term 1 co-occurred together with term 2 within the same context, however you define context, with a particular association frequency. So this is the kind of list of term pairs that you start with, and you collect this information over a large amount of text. The obvious refinements that you can do over here is you can set a certain kind of minimum threshold, and anything that does not achieve that threshold frequency you drop, because it could very easily be a random co-occurrence. You might also want to discard terms that are, okay, so why do we want to discard terms that are associated with too many other terms? That's probably because that term that's co-occurring with a lot of other terms is probably a general term. So something like, the examples given there are actually examples taken from a collection of some 100,000 documents. Words like people, state and company co-occur with a lot of other terms. So because they are general, it's not very useful to find out association information about them. So once you do these obvious refinements, you're left with a refined list of term pairs with corresponding frequencies. So if you think of, look at term 1 and look at all the terms it co-occurs with, it begins to look like something we've seen earlier. So term T co-occurs with terms T1 through Tn, and if you think of the association frequency as some kind of weight, then you can say T occurs with T1 W1 times. So this is precisely the representation that we came up with for documents. So you could regard each term now as a pseudo document. Once you have this representation, given an initial query Q, instead of searching the actual document collection using Q, what you could do is you could search the pseudo document collection. The similarity score is still the same. What's it saying? You multiply the weight of the query term, again you can take this to be 1, and the weight of Ti. So what actually are we mapping here, or what matches are we looking at? Remember, the Q as a query word also presumably has an entry in this list of associations. So what we are looking at is Q co-occurs with what terms with what weights. A candidate term T co-occurs with what terms with what weights. If both the query term and some term T in the corpus co-occur with a large number of terms in common, then the hypothesis is that they're probably related. So something like cigarette and smoking. You'd probably expect cigarette and smoking to co-occur with a large number of terms. I mean, the same terms would occur in the neighborhood of cigarette and smoking. So one kind of, the match between one single query term and T is giving you the strength of the association between that query term and one particular term T. If you add this up over all query terms, then you get a feel for how strongly related a particular term T is to the query as a whole. except that you're now working with pseudo documents rather than regular documents. So once you have a ranked list of terms, ranked in decreasing order of similarity to the query, you take the most similar terms and add them to the query. So these terms, the most similar terms, if you interpret this similarity formula, are basically terms that have co-occurred significantly with most or all of the query terms, and are therefore likely to be strongly related to the query, and therefore good expansion terms. So here's an example where the query was about a 1986 US immigration law, and you can see that it's picked up terms like amnesty program, which had nothing to do at all with the query, or these terms were certainly not mentioned by the user. These are the names of, I forget what they're called, senators or House of Representatives, I forget what they're called. They're US politicians who were instrumental in kind of formulating this law. So you can see that these had, maybe the user didn't even know these specific names and just wanted to find out information about 1986 US immigration law. And this kind of association finds useful terms like Simpson-Mazzoli to add to this query. Okay, so naturally, that's an example. So I've picked a fortunate example. But overall, on average, experiments show that this works reasonably well. Not all examples are as happy as the one I showed there, but on average, an experiment with 500,000 documents and 50 queries showed that you could obtain reasonable improvements using this kind of method, except that this work is fairly old. This work was mid-90s, I should think. So with the hardware that you had at the time, analyzing 500,000 documents and kind of finding all word pairs took 2 weeks of machine time. So with modern hardware, that will come down significantly, but on the other hand, you're also probably looking at collections that are much bigger than 500,000 documents. So if you are trying to do this more efficiently, it turns out you can, instead of using the full collection, you could pick a random sample from the collection and obtain or calculate your associations based on this sampled subset rather than the whole document collection. So, of course, you lose, the amount of benefit that you would get would, of course, go down, but it's not a major loss compared to how much time you save in terms of processing time. Okay. The last thing I want to talk about, how are we doing on time? 35 minutes. Okay, I'll finish. So the last application I want to talk about, and this is kind of very different in flavor compared to what we've been talking about so far, is something called opinion mining. Okay, so maybe before getting into what the challenges are, probably worth explaining what I mean by opinion mining. So what we want to do is, since because it's fairly easy to create content on the web, people write a lot of stuff. So a lot of people have blogs. Some of them could be kind of opinion pieces or what they think about movies, operating systems, software, anything under the sun, politics. You also have e-commerce sites. Flipkart and Amazon are two familiar examples, where along with a product description, you have either ratings or, in addition to ratings, user reviews. So suppose you want to buy something and you want to get some idea about what's the general feedback in the market about competing brands. So if you start doing this from raw data, it would take you an awfully long time. there are a number of sites where you find reviews, reviews by users or customers, and there are a number of sites where you have professionally done reviews as well. So that's a lot of raw material. So what we are looking for is ideally some technique that would kind of pick up all this material and generate a kind of basically do your homework for you and give you an easy to use summary, which says that something like the overall user impression about XYZ product is favorable, and most people kind of give it a 4-star rating out of 5 or something like that. You want that kind of a summary. So that's the problem that opinion mining wants to tackle. So this is very much kind of in contrast to what we've been talking about so far, which is mostly kind of work that was done a while back and relatively well understood and mature. Opinion mining is still very much work in progress. And you can tell, I mean, from what we are trying to achieve, that it's going to be a reasonably hard problem. So here are some of the questions that we need to answer if we were to build an opinion searching engine. So the first question is, you have a lot of pages out there on the web. If you are only interested in gathering information about a product, which pages should you be looking at? So, in other words, that boils down to a classification question. Given a document, does it express an opinion or does it not? So, refinement of that question would be, given a document that contains an opinion, what are the fragments in that document that express the opinion? So, maybe part of it is, part of a review simply tells you about specifications. So, that's kind of quantitative objective information. And then a part tells you about what works well and what does not. Or maybe a movie review, part of it tells you the story. And then part of it tells you what the reviewer liked about the movie. So you can do this, I mean, you can look at this classification problem at a finer level of granularity. Given a document that you know contains an opinion, what sections in the document contain that opinion? So, again, at the beginning I talked about structured versus semi-structured text. So here too you have the same two general classes. If you're looking at something like a blog, which is completely free form, you write paragraph after paragraph. This kind of problem is harder for documents like blogs. Whereas if you're looking at something like an e-commerce site like Amazon or Flipkart, there you usually have a quantitative component which says how many stars out of 5 or 10 or whatever. So that gives you a quick handle straight away. And you can compute something, I mean, this is something that Amazon and Flipkart already do, or something like the Play Store for apps on Android platform. You have an overall average rating. So that's one simple kind of sum. And sites where you have this kind of overall quantitative grading, that kind of averaging is fairly easy. But what you want to do ideally is something like do it at a finer level of granularity. So I'll talk about one simple example that tries to do that a little later. But the other kind of, coming back to the general problems that you have to address, once you know that, say, suppose we've solved the first two problems. So you've identified a document that has an opinion, and assume for argument's sake that you've pulled out the sentence that contains the opinion. The next thing that you need to do is you need to classify the sentiment as either favorable or unfavorable. So again, I mean, if it's grades or stars, that's straightforward. If it's kind of words, then you have to do some kind of language processing. And what makes this particularly hard is not a terribly frequently occurring feature, but it does occur and can make things fairly hard, is if a reviewer or a critic quotes somebody else ideally you want to find or you want to identify that opinion as belonging to somebody else rather than belonging to the particular reviewer. So, I mean, somebody might say XYZ said such and such thing about this movie, but I think he's wrong. So you are, in fact, I mean, if XYZ and the current reviewer are both in the same collection, you are, just because ABC has quoted XYZ, you are ending up giving, I mean, if you do things in an entirely straightforward, naive way, you'd end up giving twice the importance to XYZ than he or she deserves. So that kind of thing can get tricky, but like I said, I mean, it's probably not something that's very frequently occurring. So as a first cut, you might want to ignore this problem. The final question that you'd have to, well, the semi-final question that you have to address is, suppose you've been able to kind of gather raw material about opinions in a collection of reviews. How do you want to present this so that it's easy to use for a particular, say, potential customer? So we've already seen one simple form would be aggregation, which would be something like just calculate an average rating. Other kind of problems that you might want to tackle, again, so aggregation and highlighting are relatively straightforward. By highlighting, I mean, if you answered yes to whether a document contains an opinion, and if you've identified which portion of the document contains an opinion, then highlighting that portion is relatively easy. So then the user kind of looks at the subset of a document and does the rest of the homework on his own. Other problems of a fairly different flavor would have to do with something like community identification. Right? Given a collection of political blogs on the web, can you group people into kind of clusters based on their political inclination as supporting like party A or party B? Can you do something about estimating the reliability of a particular opinion? Right? You have, yes?
So I have a question. So opinion is an abstract concept, right?
Absolutely.
So now, as humans, we understand probably what an opinion is, but through an algorithm, so how will you say mathematically represent that, or what does it mean to the document has an opinion?
Right.
Similar to like discovering topics, right? So it's an abstract concept.
So I'll come to that. I'll give an example of some preliminary work that was done in this area, and you can see that the ideas are fairly straightforward and definitely not foolproof. So you'll be able to identify flaws, but it is a kind of first cut algorithm that you might work with to get started on this, and then like once you have an algorithm at hand, you can work on it to refine it further. So I'm still kind of talking about generalities. After this, I'll talk about one specific approach that tries to solve this problem. Okay, so the two remaining problems that I want to talk about that are of a very different flavor from everything else I've been talking about so far. One has to do with community identification, which I just talked about. And the second fairly difficult problem is estimating the reliability of an opinion. So here also you can think of what Flipkart, Amazon, or IMDb do to kind of, that's an approach to this problem in the sense that for each review, you have a potential rating for the reviewer, where you say like n out of so many users found this review useful. So that's kind of a rating for the reviewer. So that's something that some sites already provide. But that's another interesting problem to look at. I mean, what if you don't have explicit user ratings? What can you do in order to kind of estimate a reviewer's reliability? So, these are some of the questions that you might want to look at, but what I will, I forgot the last point, is that if you are kind of starting out with I want to buy such and such a product and I want to find kind of competing opinions about that product. And you go to a shopping site and you ask for this information explicitly, you're fine. So you click on some kind of a compare button. But if you expect a general purpose search engine to do this, then there's the additional final question of, I mean, given a keyword query or any kind of a query from a user, you want to identify, is the user looking for an opinion? And this is a very hard problem. I mean, you could look for, I mean, again, the first pass would be to look for particular keywords that signify user intent. Like, am I looking for reviews? I mean, does the keyword review say best 10 smartphones? So, does the word best occur somewhere, or best 10, this kind of a phrase, does it occur in my query? Best 10, top 10, something like that. So, you could start with an algorithm that's as simple as that. You look at a list of queries and you find frequently occurring patterns, and if a particular query matches that pattern, you would flag it as an opinion seeking query. But again, I mean, that's a problem that if you're a general search engine and you want to cater effectively to queries like this, that is also one of the problems that you have to solve. Okay, so this is, like I said, I mean, just a list of what kinds of problems you might need to work on if you're doing opinion mining. So here's an actual example of some preliminary work that was done in this area. So this is from about 2004 to 2006. So here the goal is you have a collection of reviews. So notice that we've already kind of we kind of sidestepped this question because we know that our collection of documents is a set of reviews. So we no longer have to worry about whether a document contains an opinion or not. So then our task boils down to, okay, so if all that we are doing is aggregation, then that's trivial. So that's not worth talking about. So the problem that I'm going to look at, or that I talk about, is something called feature-based opinion summarization. So this has two components. You have a free-form review or a collection of free-form reviews. You want to identify two aspects. One is, what are the features that people have rated? So things like, suppose we are, I mean, all of this is done in the context of digital camera review. So if you take the example from there, you might want to think of things like price, image quality, does it have an external battery, does it have its own lithium-ion battery? So these are features, size, weight, things like that. So that's one part. And the second part is, for a given feature, say weight or image quality or price, what's the general opinion about that feature? Do people think it's easy to carry? Do people think that the images are fairly good quality? So these are the two components that we'll focus on, and these are the sort of sentences that we want to analyze. So you can see, I mean, even though we haven't looked at any concrete algorithm yet, you can see that something like pictures are clear. It seems plausible that it's going to be easier to analyze this. Something, if you say something like fantastic, very compact, I mean, you can begin to, I mean, with some amount of word knowledge, you can begin to handle these sentences. But real life sentences like this, while light, it will not easily fit in pockets. We know it's talking about the size, but that's not easy to tell from this sentence. Okay, so coming back to a problem. We want to do two things: identify the features, and for each feature, you want to identify the opinion about that feature. So the very first, or the very simple thing that's been adopted here is based on the following observation. Most features are noun-like entities. So things like image quality, size, weight, price. These are all abstract nouns. And things like clear, fantastic, compact, light, these are adjectives. So, the first part, where we are trying to identify the features, involves basically, I mean, at a very simple level, identifying the parts of speech. This is something like, this is again a kind of a tool or technique that's borrowed from the natural language processing community. So people have been working on the natural language text, how you identify parts of speech. So first cut is fairly straightforward. You look up a dictionary, and the dictionary tells you or gives you a list of candidate parts of speech that that particular word can be used in. And then you could do things like look at surrounding context and determine which of those candidates has actually been used in a particular sentence. So, I mean, that's its own kind of subject area, so I won't talk about how part of speech tagging is done. But you would use this as something like a black box that's given to you by the natural language processing community. So, if you can do part of speech tagging and kind of group identification, that's technically called chunking, you do things like identify nouns, adjectives, noun groups, and so forth. So what we are interested in over here are mainly the nouns and the noun groups. So of course, in a collection of reviews, you would have an enormous number of nouns and noun groups. You want to look at kind of nouns that occur frequently, in the expectation that frequently occurring nouns probably have to do with features of the product that's being discussed. So notice that we've simplified our problem by assuming that we are dealing with a collection